Next is a video going through the questions on equation of a tangent to a circle. So first question, you're asked for the gradient of the line OP. OP is the radius. So gradient of a line, rise over run. The rise is 2, the run is 2, so the gradient is 2 over 2, which is 1. The gradient of the tangent, well, because it's a tangent, it's perpendicular, therefore it is minus 1 over 1, which is just minus 1. Now to find the equation of the tangent, we need two things. We need a gradient and we need a point that it goes through. So we've worked this gradient out from the previous question, and that's in the question. So you sub in your m, your x and your y to get c. So subbing in from the coordinate y, m, x, you'll see that c is equal to 4. So we want to write it y is equal to mx plus 4, and we're going to substitute in the m that we've worked out and the c that we've worked out. So that gives us y is equal to minus 1x plus 4. Question 2. So the gradient of the line OP again, the gradient of this radius, rise over run, is 3. The gradient then of the tangent is minus 1 over 3. The equation of the tangent, we use this. This is our m. And we use our coordinate. We plug it into y is equal to mx plus c. So m is a third. There's x, there's y. Plug it all into here to work out what c is. C is 6 2/3 or 20 over 3. Then you can write it as y is equal to mx plus 3. Either way. Next question is x squared plus y squared is 29 through the point minus 5, 2. So the gradient of the line OA is the rise over the run. So the rise is 2 and the run is actually minus 5. So it's a negative gradient. But you can tell by the direction of the line anyway. Therefore the gradient of the tangent is minus 1 over that, which is 5 over 2. So we have the gradient of the tangent. We have a coordinate that it goes through from the diagram, minus 5, 2. So we plug all of this information in to y is equal to mx plus c, and we get our value of c, and then we do y is equal to mx plus c. So y is equal to 5 over 2x plus 29 over 2. Question 4. We're just straight away asked for the equation of the tangent, so we have to break it down into steps ourselves. So we have to draw a radius and then get the gradient of that radius. So the radius here is the line OP, and the gradient rise over run is minus 4 over 2. It's a downward slope, minus 4 over 2, which is minus 2. So if the gradient of the line OP is minus 2, then the gradient of the tangent is a half. And it goes through 2 minus 4. Plug this information in, you get c is equal to 5. Therefore, our equation is the equation of the tangent is y is equal to a half x minus 5. Similar question again, we're asked for the tangent straight away. So we need a radius and we need a gradient of that radius. And how do we get the gradient of the radius? We need the rise over run. And where do we get the rise over run from? From this coordinate 6, 8. So we go across 6 and up 8. That means that the rise is 8 over 6 or 4 over 3. So the gradient then of the tangent is minus 3 over 4. And it goes through this point. So plug it into y is equal to mx plus c. And you'll get your value of c, which you can use to finish the question. Y is equal to minus 3/4 x plus 12.5. Question 6, we have equation of a circle and we have a point. The tangent goes through the point or touches the point 2, 8. We're looking at the equation of that tangent. Now because 2, 8 is the coordinate on the circle, well, then we can draw just a wee sketch of a radius. And we can see that you go across 2 and up 8 because it's the point 2, 8. Therefore a rise over run is 8 over 2. The gradient of the tangent, the gradient of the radius is 4. The gradient of the tangent therefore is minus 1 over 4. Goes through this coordinate, sub it in, you get your c value, and then your y is equal to mx plus c. Question 7. The question has the equation and has the diagram. It says point P lies on the circle and it only tells us the x coordinate, so we need to work out the y coordinate. So plug in x is equal to 1 into x squared plus y squared equals 17. And you'll see that the y coordinate is 4. So that means that point P is 1, 4. From that we can get the gradient of this line OP, of the radius. So raise over run, the gradient of that radius is 4. Therefore the gradient of this tangent is minus 1/4. So we have the gradient, we have a point it goes through, y is equal to mx plus c, work out c, and then plug it back into mx plus c. Question 8 is a good bit harder. That's not to say that it hasn't been hard so far, but question 8, let's read it, the line L. So this is L, line L is tangent to the circle, x squared plus y squared equals 90 at the point P. So there's P, and the point P is 3, 9. The line L crosses the x-axis at point Q. There's Q. Work out the area of OPQ. So O is the origin. So we're looking at the area of a triangle OPQ. So let's just show you where that triangle is. The triangle OPQ is here. So to get the area of a triangle, we have to do half times the base times the height for any triangle. So we need to get the base, we need to get the height. Now the base is something we can't get straight away, but the height we can get pretty easy. Because that coordinate P is 3, 9, that means that to get to 3, 9 from the origin, you go across 3 and up 9. So from there we can say that the height of our triangle is 9. And also that coordinate 3, 9 allows us to get the gradient of this radius OP. And that's what we'll do now. So we're going to calculate the gradient of OP, rise over run, 9 over 3, which is 3. Why do we do that? We did that so that we can get the gradient of the tangent. The gradient of the tangent is minus 1/3. Now that tangent goes through the point 3, 9, so we have enough information here to get the equation of the tangent. So y equals mx plus c. Sub in your y, your m, x to find out c. And move that across, c is 10. Therefore the equation of the tangent is y is equal to minus a third x plus 10. So this line here has the equation y is equal to minus a third x plus 10. Now we're looking at the area of a triangle, remember, so we have the height, we're looking for the base. So how does that equation help us to get the base of a triangle? Well, because this is the equation of the line and it crosses the x-axis, it crosses the x-axis whenever y is 0. So let the equation be equal to 0. 0 is equal to minus a third x plus 10. Rearrange a third x equals 10. So x is 30. So the x coordinate of this point is 30 and the y coordinate is 0. And because the x coordinate is 30, that means we now know the base of the triangle. The base of the triangle, it goes from 0 all the way to 30. The height of the triangle is 9. So the area of our triangle, so half times base times height, half times 30 times 9, which is 135 square units. So very hard, like I said. So if you follow that, even if you haven't attempted it and you followed it alright, that's pretty good going. Question 9 is another tricky one. So we have the equation of a circle. We can tell from that the radius is 5. Two tangents touch the circle at points A and B and they meet. We want to find out where they meet. So to find out where two lines meet, you just let the two lines be equal. And to do that, we need equations of both lines. So let's start by getting actually the equation of this tangent. It is the harder one to get. But we'll get the equation of this tangent first. So to do that, what we need is, we need to think about the radius out to that point. So the radius is OB. So let's try and get the gradient of OB. So the gradient of OB will use the coordinates of B. B is 3 minus 4. So we go out 3, across 3 and down 4. So the rise is negative. The gradient is minus 4 over 3. Remember, rise over run. Therefore, the gradient of the tangent is 3 over 4. Now it goes through the point 3 minus 4, so we can get the equation of this tangent. And remember, we're just talking only about this tangent at the minute. So y is equal to mx plus c, using this information, m, and our coordinate. So y, there's minus 4, is equal to 3/4 times x plus c. C therefore is, if you bring that, that's 9 over 4, and subtracted from so minus, let's change the pen. So c is minus 25 over 4. So then we have an equation of our tangent. Y is equal to 3/4 x minus 25 over 4. So that is the equation of this tangent. Now we need the equation of this tangent. And then we're going to let them be equal. So what is the equation of that line? So that line is just a horizontal line. It's a horizontal line that goes through the coordinate 0, 5. So the y value is always 5. So the equation of this line is y equals 5. So we have two equations, y equals 5, y equals 3/4 x minus 25 over 4. If we want to figure out where they meet, well, then we let them be equal. 5 is equal to 3/4 x minus 25 over 4. So you can bring this over. 5 plus 25 over 4, and you can use your calculator, is 11 1/4, and that is equal to, that's not 1/4, 11 1/4, and that is equal to 3/4 x. So you can bring the 4 up, multiply, and then divide 3 by 3. You get your x value to be 15. So the x value of p, the x coordinate of p, this point, is 15. Now what's the y value? The y value is 5. Because it goes through this line, all these points are where y is equal to 5. So our answer is 15, 5.